Good morning to one and all. Very warm welcome to all after your holidays. Now it's time to learn some new concepts. We have to upgrade ourselves. So today we are going to discuss about force and pressure. Force and pressure. This is the concept map of force and pressure. Once we look at this concept map, here the main theme of the lesson is nothing but force, and we have to know the applications of force in our daily life. And the classification of forces. Force is classified into two types. Those are nothing but contact force and non-contact force. And what are the types of forces that are present in contact force? Muscular force, frictional force and mechanical force. And we have to know that what is muscular force and what is mechanical force and what is frictional force and what is friction. How can we reduce friction in this lesson? Not only that, we have to know the types of non-contact forces. Here magnetic force, gravitational force, electrostatic force. These are also applications of force. Okay, in this lesson we are going to learn about all these things. So this is the word web, the main words which are present in the lesson. Let us look at this word web. Here magnitude, and the second one muscular force, friction, mechanical force, gravitational force, electrostatic force, Newton, Pascal, manometer, pressure, vacuum, atmospheric pressure. Atmospheric pressure. These are the important words that we are going to learn in this lesson. So, first of all, we have to know what is a force. Before going to learn about force, we just recall our previous knowledge. Okay, children, once recall in your previous class, what are the organisms? What are the different types of organisms that you may know? Once think about it. Yes, mainly we have two types of organisms. Those are nothing but living organisms and non-living organisms. Living organisms and non-living organisms. Could you give some examples for living organisms? Could you give some examples for living organisms? Once think about it. Yes. Humans, animals, insects. These are living organisms. What about non-living organisms that are present in our classroom? What are the non-living organisms that are present in our classroom? Here, duster is a non-living organism. Blackboard is a non-living organism. And bench is a non-living organism. Etc. So many examples are there. But while we consider our classroom examples, I think these are the sufficient one. Okay. Now, living organisms can move one place to another place for food and shelter. Yes, you got that? Living organisms move one place to another place for food and shelter. Then what about non-living organisms? These non-living organisms move themselves from one place to another place? Is the duster and the blackboard can move from one place to another place? No, they can't move. In order to move these non-living organisms, we have to apply some pull or push on those objects. We have to apply some pull or push on those objects. So, now we have to know what is pull and what is push. What is pull and what is push. See, to move an object away from our body, to move an object, here duster is an object, I am moving the duster away from my body. To move an object away from our body is called push. To move an object towards our body is called pull. See, in the classroom, to open the door, what I have to do? I have to pull the door to open it. To close the door, I have to push the door. Okay, pull means to move the object towards our body is called pull. What is push? To move the object away from our body is called push. Now, try to give some real life examples regarding pull and push. Try to give some real life examples for pull and push. Once recall your day-to-day activities and observe where you are applying pull and observe where you are applying push. And give some examples related to pull and push. Okay, did you got that? See, while our bicycle is stopped, we have to apply some force to move our bicycle. To move our bicycle, we have to apply some push. So, while we went to supermarket to buy some goods, we have to move the trolley. See here, we are moving the trolley away from our body, so we are applying push. That means while moving trolley. What about pull? Did you get any real life examples related to pull? Yes, while opening a door, we are applying pull. While opening the door, we are applying pull. Or while we come to school, we have to lift the bag. While lifting the bag also, we are applying pull. In our real life, in so many situations, we are applying pull and push. So now we are very close to force. By using these pull and push, we can define force. So, what is force? Any pull or push or both is called as a force. What is force? Any pull or push or both of an object is called force. Okay, now we have to know that in our real life, in which cases we are applying both pull and push. That is the main thing. See, this is the duster, this is the blackboard. While rubbing the blackboard, we are applying both pull and push. So this is one of the example related to both pull and push. See, while cutting a wood, the carpenter must apply both pull and push to cut the wood. Yes. While cutting a wood with the help of the saw, the carpenter has to apply both pull and push. While playing a guitar, they have to apply both pull and push on the guitar. So, what is force? Any pull or push or both of an object is called force. Now, it is very clear that today we learn what is force. Any pull or push of an object is called force. Is it clear, children? What is force? Any pull or push or both of an object is called as force. Now we are going to learn about force. Okay. Force. What is force? A force is a physical quantity. A force is a physical quantity. So what is meant by physical quantity? Here force is a physical quantity. That means force existed in our physical world. We can't touch the force, but we can experience the effects of force in our daily life. We can't touch the force. But we can experience the effects of force in our daily life. Then what is the meaning of quantity? Which is measurable, that is called as quantity. Which is measurable, that is called as quantity. Mainly we have two types of quantities. Those are nothing but fundamental quantities and derived quantities. Now let us look at this to learn about types of quantities. Quantities are mainly classified into two types: fundamental quantities and derived quantities. What are fundamental quantities? Mainly, we are saying that we have three fundamental quantities. Those are nothing but length, mass, time. But actually, we have seven fundamental quantities. What are those? Here, length, mass, time. These are three fundamental quantities that we know so far. Now we are going to learn about the remaining fundamental quantities. Temperature, electric current, quantity of matter, and luminous intensity. Here length, mass, time, temperature, electric current, quantity of matter, and luminous intensity. These seven are known as the fundamental quantities. Among these seven, we are mainly related with length, mass, and time. So that's why we are discussing about length, mass, and time. So these are the seven fundamental quantities. Then what are derived quantities? The quantities which are derived from the fundamental quantities, those are nothing but derived quantities. The quantities which are derived from fundamental quantities, those are called as derived quantities. So what are the examples for derived quantities? So let us look at the example for derived quantity. See here, area, volume, all these are examples for fundamental derived quantities. Area. How area will be the best example for derived quantity? How can you say that area is an example for derived quantity? Why? Because to measure the area of a classroom or a place, we have to know the length and breadth of that place. Length and breadth. Here, length is a fundamental quantity. Here, length is a fundamental quantity. So, here to calculate the area, we are depending upon length of the object. That's why here area is considered as derived quantity. Not only that, if we want to calculate the volume also, we have to depend on the length of the object. Volume is defined as the product of length, breadth and height. Here length, breadth and height is also called as fundamental quantities. Here volume is mainly depends upon the fundamental quantities. So volume is also a derived quantity. So this is the concept related to different types of quantities. To measure the quantities, we have systems. To measure the quantities, we have systems. Now let us discuss about the types of systems. Mainly, we have three types of systems to measure these fundamental quantities and derived quantities. We have three types of systems. To measure quantities. The first system is nothing but MKS system. Second one, CGS system. And the third one is FPS system. These are three types of systems which are used to measure quantities. So, the first quantity is length, second one mass, and third one time. So, in MKS system, what is the unit for length? Here M means meter. Yes. The unit for length is meter. In which system? In MKS system. What is the unit for mass? Here K is there. K means kilogram. K means kilogram. It is also well known that kilogram also called as kg. Then what is the unit for time? The unit for time is second. The unit for time is second. Now in CGS system, what is the unit for length? Here C means centimeter. C means centimeter. What is meant by G? G means gram. Yes, grams are used to measure mass. What is the unit for time? The unit of time is nothing but second. The last system, FPS. What are the units for length in FPS system? Here F means foot. Yes, it's foot. Foot is the unit for length in FPS system. What is P? P means pound. P means pound, and it is the unit for mass. The last one, S means second. S means second. Okay. We have mainly three types of systems to measure units. What are those? MKS system, CGS system and FPS system. These systems are used to measure quantities, length, mass and time. Okay, what is clearly observe this and I will ask one question. Get ready with your answer. Okay, which physical quantity remains same unit in all these three systems? Which physical quantity has same unit in all these three systems? In all these three systems. What is your answer? Yes. Time is a unit. Time is a quantity which has same unit in all these three systems. See here in MKS the unit of time is second, and in CGS also second, and in FPS also time has the same unit second. Okay, so MKS system is also called as SI system. SI system. What is the meaning of SI? SI means System of International. SI means System of International. Here, System of International is also called as International System of Unit. International System of Unit or System of International. So, to measure a physical quantity with the same unit to the worldwide or internationally, SI system is developed. We are using the SI system in our lessons. So that's why I have just given the introduction for the SI system. Okay, is it clear, students? So far we discussed about force and types of quantities and the types of systems that are used to measure quantities. Okay, see what is force? Any pull or push of an object is called force. Yes, force is a physical quantity. We can't touch the force, but we can experience the effects of force. Okay, now force has both magnitude and direction. Force has both magnitude and direction. Before going to discuss about this point, we have to know what is magnitude. What is magnitude? If your mother said that, please go to supermarket and buy a 5 kg of rice packet, what you will do? We will go to the supermarket and definitely bring a 5 kg rice bag from the supermarket to our house. So, what is the quantity of rice? Yes, 5 kg. 5 kg. We know that kg, kilogram, is a unit for mass. Here, 5 means that represents the how much quantity you are going to bring to your house. So here the numerical value which is present before the unit. The numerical value which is present before the unit is called as magnitude. What is magnitude? The numerical value which is present before the unit, that is called as magnitude. That is called as magnitude. The numerical value which is present before the unit, that is called as magnitude. What is the height of a person or something else? The height may be measured in meters or in centimeters. Let it be 6 meters or 7 meters. 7 meters. What is the magnitude? Here, if we say that 7 meters, the height of some particular thing is 7 meters. 7 is considered as magnitude, and meters is the, what is the meters is the unit. Okay, you get that? What is magnitude? The numerical value, let it be 1, 2, 3 up to etc. Whatever may be the number that could be present before the unit, that is described as magnitude. That is described as magnitude. So every physical quantity in the universe has magnitude. Every physical quantity in the universe has magnitude. Now we are going to discuss about the force. Force has both magnitude and direction. What is meant by direction? See the duster clearly. If we apply some force on the duster, in which direction it will move? Applied force in right side direction, so it moves towards right side. Now applied force in the direction of left side, so it will move in left side. Now I applied force away from our body, that means towards, not towards you. Okay, towards you I applied some force. So that's why the duster travels away from my body and it travels towards you. Okay. See. Now what will happen? Applied force towards myself. So the duster moves towards myself. So force has direction. In which direction we will apply the force, in that direction only the object will move. In which direction we will apply force, in that direction only the object will move. So by observing these two things and by listening these two things, we can easily say that force has both magnitude and direction. Force has both magnitude and direction. So, a physical quantity which has both magnitude and direction, that is called as vector quantity. That is called as vector quantity. What is a vector quantity? A physical quantity which has both magnitude and direction. That is called as vector quantity. So here force has both magnitude and direction. So force is classified as a vector quantity. So force is a vector Force is a vector quantity. So far we have discussed so many things related to force. We just recall these things. Okay, what is force? Any pull or push of an object is called force. Force is a physical quantity. We can't touch the force, but we can experience the effects of force in our daily life. in our daily life. So force has both magnitude and direction. Force has both magnitude and direction. So force is classified as a vector quantity. Force is classified as a vector quantity. What is vector quantity? A physical quantity which has both magnitude and direction, that is called as a vector quantity. What is magnitude? The numerical value present before the unit is called magnitude. Okay, in the next session we are going to discuss about the types of forces and effects of forces. Okay, thank you.